Carbon nanotube use in protective materials. As we experience the impact of a global pandemic due to the outbreak of the 2019 novel coronavirus, research regarding protective textiles is more important and relevant than ever before. The molecular structure of protective materials is shifting from strictly polytetrafluoroethylene to a hybrid composed of carbon nanotube forests. Why carbon? Carbon is known for its ability to build stronger and more complex molecular structures than any other element. Carbon nanotubes were discovered in 1991 by Sumio E. Jima. Nanotubes are extremely small. They are about 5,000 times smaller than the diameter of a human hair. Nanotubes function as pipelines to conduct electricity. They have the capability to filter certain particulate matter, such as chemical compounds, bacteria, and viruses. Current hazardous material protective wear is able to protect wearers from chemical, biological, and viral compounds. The issue with these materials is that they do not provide a channel for water vapor and air to escape. Therefore, these materials can only be worn for periods of 1 to 2 hours at a time, which greatly reduces their functionality. Because of the restrictive nature of current hazardous protective materials, there's been a push towards smart protective materials. Scientists based out of Lawrence Livermore National Laboratory have been conducting research using carbon nanotube-based membranes to measure the breathability of material versus the moisture vapor total resistance. On this chart, you'll notice that the materials with the highest resistance to particulate matter, as well as high breathability, were developed by the scientists at Lawrence Livermore using carbon nanotube-based membranes. Scientists in Lawrence Livermore National Laboratory have been working on a material called second skin. This responsive material has been incorporating carbon nanotube technology into making breathable protective textiles that can be worn for long periods of time. However, some viruses are still small enough to penetrate the protective materials, which has led scientists to develop responsive smart materials. These materials are composed of nanotubes, which will be fitted with sensory molecules that respond to and block hazardous materials such as small viruses and harmful chemical compounds. The Department of Energy at Lawrence Livermore National Laboratories has been funding a group of scientists working on the second skin applications. They have been working on carbon nanotube-based protective materials that will likely be available within the next 10 years. At first, second skin textiles will mostly be used for first responders, soldiers, and hazardous material response units who come in close contact with harmful chemical, bacteria, and viral compounds. However, it's estimated that at some point within the next 20 years, protective textiles will become available to a mass market. Carbon nanotube technology is an expanding industry with many different applications. Some of those applications include energy. For example, lithium metal batteries are including carbon nanotubes for faster charging and a higher capacity. In the medical world, artificial muscles are being composed of nanotube yarns that are filled with wax, and these muscles have the ability to lift weights heavier than 200 pounds. And in the environment, carbon nanotubes are being used to clean oil spills by adding boron atoms to carbon nanotubes in their growth stage. When they do grow, they grow to sponge-like materials that can absorb many times their weight in oil.